deviation. Now, it should be noted that you are not required to find the standard deviation which we have the Sx or sigma x. These are both the notations that we use. But you should be able to approximate from a graph or data. So you don't need to be able to calculate now the form, because here's the thing, the formula itself is a little bit ugly, all right? And we are not going to, at least for now, later on in this course, there is a part where you have to plug into the formula. But the good news is that while there is a formula, you get what's known as a formula sheet. And so you need to plug into the formula later on in this course. I'm talking about like months from now, to show that you know what you're doing. All right. And then that's basically it. So you don't really need to know about that right now. So it's not required to find the exact, but you should be able to understand what the meaning of a standard deviation is, how to approximate it based on the graphical distribution, or if you have concepts about the data, you should be able to find it as well. So, in layman's terms, the standard deviation, and it's not a beautiful definition, but it gives us a good understanding of what the standard deviation means. It means an average, standard deviation is on average how far the data is from the mean. All right. Sometimes we will say this as the average distance from the mean. So what the standard deviation is kind of telling us mathematically is, on average, how far away is the values from what the average actually is. So if you had a quiz, so for example, i.e. there are 2 quizzes, both with a mean of 60. One quiz has a standard deviation equal to 5, while the other is 20. Okay, so two quizzes, they both had the same mean. The average score on the quiz was a 60. So did the class perform the same on these quizzes? Well, their average was the same, but remember, what we have to learn as students now in statistics is that the average, a measure of center, doesn't paint the whole picture. We need to talk about the spread. And so if we think about the first quiz, so here's the first quiz, and, well, actually, so here's a 60, and here's a 60, 55, 50, 65, 70, 65, 70, 55, 50. The first quiz will look like this with the scores. If we did a histogram and we kind of like did it, the first quiz will kind of look like this. Notice the peak is right around 60, the center, the mean, seems about right. And most all of the scores are between 55 and 65 because the average distance was right around here, around 5 units away, about 5 points away from the center. However, we can also talk about a quiz that has 60, but their graph looks like this. And in this case, most of the scores are actually going to be between 40 and 80. So most of the scores, because the standard deviation is around, it's going to be over here around 80 and 40, because this one has a standard deviation of 20. Or sorry, oops, yes, yeah, I'm right. What would you say about these two quizzes? What is the difference? Can you, what could we say about this first quiz? They're both around 60, but what can you tell me about the standard deviation, and what does that tell me about the spread? Just need some dialogue going. I'll wait.
Can you please repeat the question?
Well, what would you think about these scores from this first quiz versus the scores on the second quiz? Or what would you say about these scores?
Just from looking at it, I mean, the scores are on the same range, but the first one is more, like the way that it's drawn. It shows that the people in the first quiz kind of all got somewhere in the 60s and 65.
We call this the math the word is consistent. That I think that's what you were trying to say.
And then for quiz 2, not really.
Scores, and I'm gonna go with all over the place. Okay, well, in the first quiz, now the average was still a 60. It doesn't matter if you took quiz 1 or quiz 2. The average score was a 60. All right, but on the first score, basically what that tells me as a teacher, for example, is, a 60, right? Wow. Well, if this was just, for example, if I expected the average to be higher, and I look at this and I go, wow, the average score was a 60. That's not too good. And most all the class got around a 60. That tells me as a teacher, I probably didn't teach very well because most of the students in the entire class are scoring right around that 60. Very consistently around 60. I look at the second quiz and I go, well, there's something it's not necessarily might be what I'm teaching, but maybe in regards there needs to probably some other type of factor that's going on in the class because the scores are all over the place. I probably had a student who scored 100 on the quiz, and I probably had a student who scored a 20 on the quiz. So the scores are all over the place. The average spread or average distance from the mean is a 20 on the second one. That means the scores are less consistent, and we're going to talk about comparing on Friday. That's one of the main things we're going to be doing on Friday's lesson, comparing if one was 5 and one was 20. But they're much more spread out. The average distance from the center is much greater for quiz 2 than it is quiz 1. So that's kind of what standard deviation tells me. That's what spread in general tells me. Okay, so that's what spread in general tells me. Now, if I'm looking at a graph, all right, I have like, this, I have the histogram. And we know that from this histogram, the mean is probably right here, right where the center is, right where that mound, that mode, not the mode, but the modal, the unimodal piece is. And this point right here, this is what we call a point of inflection in algebra. it's where the graph changes from from like curving down to curving back up. But what we can identify is that if we take this part right here where the mean is, and we take that point over there where that part distance is, that's kind of where we would start saying where most of my data is between. The distance between here and here is what we refer to as a standard deviation. One standard deviation. All right, so the distance between the center and where that goes is about one standard deviation. So over here, this is about one standard deviation as well. All right, so a standard deviation is not all of the data. It's kind of where when I kept asking those questions, where is most of my data? And we said, oh, most of my data was between 40 and 80. Well, that covers a standard deviation below and a standard deviation above. I would expect the majority of my data, most of my data, to be between about one standard deviation less than my mean and one standard deviation above my mean. Below. So that's a very important concept that we're going to go into. Okay. So in some of your problems in tonight's homework, you're going to be given a graph, a histogram, a stem plot, or something like that. Some problems you're going to be just dealing with, context problems. Some of you might be like, I don't, and it might happen, just like I know there was that problem I think Anne was bringing up and didn't, the context of the problem might be a little bit tricky, like you don't know what those look like. Email me up and I'll kind of give you an idea of what they look like. Or Google, if there are any instances of that. But you should have an idea. What does an average look like? Okay, what is a typical? All right, what is a typical? And what would you consider a good amount? And what would you consider not that much? And the distance between a good amount and the typical is typically the mean, the standard deviation. The standard deviation is typically what I say, a good amount minus a typical. I know that's not a statistical way of doing it, but basically that's kind of the calculation you're doing, and you're going to be making some estimations. Most of the times we just want to make sure you're in the right, ballpark. For example, if I told you, how much cash do I have in my wallet, or I have money in my wallet, what would be a standard deviation? All right, you'd probably think like a standard deviation might be like anywhere between $20 and $40 might be a good idea. I would expect Mr. G has around $40 in his pocket. Maybe he has like $60 in his pocket, $80 in his pocket. So if you gave me any answer for a standard deviation like in the teens, it would make sense. Now, if you said my standard deviation was, let's say, like 10 cents, like a quarter, that doesn't seem like, because how much money I have in my wallet probably varies a lot more than just like a quarter. But if you told me $100 or $200, I think the standard deviation of how much money Mr. G has in his wallet is $200. One of two things. A, you think I have a lot of money and you think I walk around with a lot of cash on hand. Or B, you don't understand the idea of a standard deviation. So maybe you do. Maybe you feel, and you could remember, these are one of those questions where you can get the wrong answer but still get full credit. And if you explain, well, I think the standard deviation is 200 because I think Mr. G's a baller and he's walking around with bills all over the place. Okay, I would give you full credit because you understand the concept of a standard deviation. Now the expected answer is probably anything within $10 to like $60 would be just like, oh, yeah, I would expect him. Like I would expect me to have about that much cash on hand. Now, the formula. Now, remember, before x equals a data point, x bar equals the mean, n equals the sample size. In calculating the standard deviation, we first need to start with x minus x bar. We refer to this as a deviation. How much does a single data point deviate from the mean? That's the distance, okay? The next part of the formula, we're building the formula. The next part of the formula is that we're going to take how much they deviate, how much something deviates, and we're going to square it, okay? And the reason why we square it is because we want deviations. There's two reasons. One, deviations below or above should be counted the same. And if you square a number, remember, well, no matter what, when you algebraically, if you square a number, you always get a positive. And two, outliers should weigh more heavily. So if you have somebody that's like 100 away, where everybody else is like 5, 6, 7, that one that's 100 away is going to make the standard deviation look a lot bigger. So we square it. Outliers are more problematic. And we square it because we want them all to be positive. Next part of the formula, summation. I showed you that formula. X minus x bar squared. We're going to add all the square deviations. And the final part of my formula is that the standard deviation is equal to the square root of the summation of x minus x bar squared over n minus 1. I undo, I divide by n minus 1, and then I undo the square. Now, a lot of students go, why n minus 1? Why are you dividing by n minus 1 and not n? And the reason is, if you only have one value, if you only have one data point, only one person responds, there is no standard deviation. So if you have 1 and you take 1 minus 1, that's 0. If you divide by 0, you get undefined. So in other words, you need at least 2 data points to find a standard deviation. That's basically why we're dividing by n minus 1. And then we take the square root. Well, once again, you don't need to know this formula. The formula will be given always given, but don't need to use at this point. Understand the meaning. That's what's more importantly. And the way this formula looks, if we wrote this out the long way, is S of S, the standard deviation equals x1 minus x bar squared plus x2 minus x bar squared plus dot 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 plus xn minus x bar squared all over n minus 1. That's what that formula looks like. And if you're, please do not get intimidated by this formula. You do not need to use this formula. I need you to understand some of these concepts right here. We're talking about deviations from the mean. We're talking about average deviations from the mean. And as such, we need to square the values. So negatives and positives below mean and above mean will come in the same in the calculation. And outliers are more problematic. Outliers, because when you square an outlier, if you take an outlier and you subtract the average, you're going to get a big number, and a big number squared is a really big number compared to a little number squared. We want to take that into account. What you also need to know is that standard deviation, because outliers are problematic, it is non-resistant. Outliers will change your standard deviation. An outlier will change the standard deviation. The interquartile range, IQR, is therefore what? If the standard deviation is non-resistant, what is the IQR? What is the IQR? If the standard deviation is a non-resistant measure, then what is the IQR?
A resistant measure?
Yeah. IQR is not affected by an outlier. If you have only like one outlier, it's not going to drastically, or it might not even affect the IQR at all. So if you have one outlier, your standard deviation is going to change because it's not resistant to it. It's like, oh, I give up. You know what? I'll follow you. You got 100 on your quiz. These are the people kind of like, well, so and so didn't study for their quiz and they got a 95, and you're like, I'm going to believe that. I'm going to go because my standard deviation is going to take me over there. That's non-resistant. You're just going to go with it. But you got to realize that doesn't really change how everything really works out for the average, the typical population. So a better measure would be something that's that is a resistant measure, such as the IQR for the spread and the median for the standard deviation. One does not change at all. So when we talk about the measures of spread, the measures of center and spread, we have those that are resistant to outliers, and we have those that are non-resistant to outliers. Which measures of center and spread are resistant to outliers? What two measures are resistant to outliers?
Mean and standard deviation.
Get them backwards. Resistance means you put up a fight. Means that you don't go over. You don't. It's
Median and interquartile.
Yeah, median and interquartile range. Non-resistance means, you know what? I'll follow you. Yeah, that's what you say. Okay. You're not resistant much. You're just going to give up the fight. Like, wow, look at that outlier. I'm going to go follow it. I'm going to change because of that one person. That's non-resistant, which is the mean and standard deviation. So you remember, to use the mean and standard deviation, the distribution must be symmetrical and no outliers as a result. So in statistics, we want to use the mean and standard deviation because there's more mathematical properties that we can do with the mean and standard deviation. However, in order to utilize them, the distribution must be symmetrical with no outliers, because if the distribution is not symmetrical, then your mean and standard deviation aren't going to be very reflective of the real population, and the same thing if there's an outlier as well. Example. Which has a larger standard deviation? Okay. The first one is 1, 2, 3, 4, 5, 6, 7. This is set 1. and set 2 is 1, 1, 1, 4, 7, 7, 7. Which one of these has a higher standard deviation? Now, I want to point out that both of these have a mean equal to 4. Both sets have a mean equal to 4. Which one has a higher standard deviation and why? Which set? Set 1? And this is also like in your homework, there's a lot of confusion. A lot of people try to like find the standard deviation. Like you're going to see set 1 and set 2 for each one. And so for each set, you're trying to compare and it'll look very similar. This one might even be one of your homework problems. Which one has a higher standard deviation? Without going to your calculator. Once again, you can input the values into your calculator and do a 1-var stats. You can do that, but that's not the point of the emphasis on the problem, and you will get minimal to no credit on it because you're trying to understand why without, and the instructions will say without finding the actual standard deviation. Which one has a higher standard deviation, set 1 or set 2? Now the min and the max are both the same for both of these. The mean is both the same. They're both symmetrical. So which one has a higher standard deviation?
Set 1, I think.
No, it's actually set 2. It's actually set 2. It's actually set 2. Can someone try to guess why set 2 then? You can give me the answer in talking about why set 1 isn't, or why set 1 has smaller, or why set 2 has bigger.
Is it because set 2 has more values away from the mean?
Good. You can also say because set 1 has more values closer to the mean, but just saying the opposite, right? So set 1 has more values closer. The 2 and 3 are a lot closer than the 1 and 1s. So if you go apples to apples, the 1 and the 1, okay, that's going to be the same. The 2 and the 1, oh, the 2 is closer to the mean of 4. The 3 and the 1, oh, the 3 is closer to the 4. The 5, oh, the 5 is closer than the 7. The 6 is closer than the 7. So when you look at all of the deviations, set 1 has a lot more deviations that are closer to the mean, where set 2 has a lot more deviations that are far from the mean. And when we square those, they're going to be becoming greater parts and issues. So when you're doing problems, the ideas are always the same, very much similar to the homework problems last night. Sometimes you're going to add or remove a data point. Okay? You're going to add or remove a data point. Okay? If you add a point close to the mean, and it doesn't matter if it's below or above, the standard deviation will what? What will happen to the standard deviation? Increase or decrease? You add a new point to my data that's close to the mean.
Decrease.
Will decrease. So if here's the mean and you add one more value here that's close to the mean, the data is going to get a little bit more consistent. It's going to be closer. Now, a lot of people try to look at the value, and here's the biggest mistake you're going to make. You're going to look at the actual number value, and you're going to like, oh, that's a positive number, or that's a negative number, or it's below the mean, it's above the mean. No, is it close to the mean? All right. And of course, removing is opposite. if we remove a point close to the mean, what will happen to the standard deviation?
Increase.
It will increase because now your data is more spread out because that value that was close to the mean helped make it more smaller. And the other one is we're going to change a value. So if you change to something closer to the mean, now it doesn't mean if you make it increase or decrease the value. If you make it closer to the mean, then the standard deviation will do what? You take a value and you're like, oops, that was a mistake. And the new value is actually closer to what a typical value is. What will happen to the standard deviation?
It'll decrease.
Yeah. And same thing, further away is the opposite. It'll make it bigger. Okay. So your homework, I don't want to go to a new page. I guess I'll go to a new page. Homework number 12, chapter 4,